Okay, so chapter 7 gets in this thing called arrays. And the book says that an array can hold multiple values of the same data type simultaneously. What I want you to think of an array is, think of it as a bookcase that has no shelves. Okay, so we're going to declare this empty bookcase, and then we're going to tell it how many different shelves it's going to have. And the way we do that, in this case, we're going to create an integer, an array. We would type int, left square bracket, right square bracket, and then numbers. So the name of the array is going to be numbers. Think of it like a variable. So right now, after I do this line right here, we have an empty bookcase. We don't know how many shelves are in it. Now we come down here, you'll notice I say numbers equals new int 6. What we did there is we now said this bookcase is going to have 6 shelves. And those shelves are going to be numbered 0, 1, 2, 3, 4, 5. We always start with the number 0 when we declare arrays. So it's a 6, this bookcase has got 6 shelves. And the only thing that can go into these bookshelves are integers. That's the only thing that can go in there. And again, they're numbered 0, 1, 2, 3, 4, and 5. So, so this is kind of how it looks. So I got this numbers variable as an array, and we've declared it with 6 shelves. And here's element 0, element 1, 2, 3, 4, and 5. So, now we could do it in one statement. Instead of doing it in 2 statements, we could just say int, left and right square bracket, numbers is equal to new int 6. So that basically says we're going to create a bookcase, otherwise known as an array, that's going to have 6 bookshelves in it. We could do the same thing with float. We could do the same thing with char, long, and double. So float would be left and right square bracket, temperatures is equal to new float 100. There's going to be 100 bookshelves on there. And they're going to be numbered 0 through 99. Another way we could do it with a constant. In this case, we've got a constant called num elements. It's set to 6. So I create a new array, an integer array called numbers, and it's going to be instantiated as a new int array with 6 elements in it, 6 bookshelves. And again, yeah, the bookshelves are numbered, otherwise known as subscripts. So 0, 1, 2, 3, 4, and 5. And if I want to put a number in one of these shelves, so for example, in shelf number 0, I want to put the number 20. I would say numbers inside the left and right square bracket would be the number 0 and 20. So up here in this bookshelf, we're going to put the number 20 right in here. And down I got numbers 3 equals 30. Over here in the third bookshelf, we're going to put the number 30. So what we basically have is a variable that can hold multiple values. So here's numbers 0 has 20, numbers 1 still has 0, numbers 2 has 0, numbers 3 has 30 because we just execute those 2 lines, and the rest of these bookshelves have 0 in them. So let's do this. Let's open up Array Demo 1, and let's take a look at what this looks like. So here I've got Array Demo 1. Here's my public static void main. I've got final int employees equals 3. So I create a constant called employees, and it's going to have the number 3 in it. Then I'm going to create my hours array. It's an integer array. The only thing that can go in here are integers. There's my left and right square bracket. Hours is instantiated as a new int array with 3 employees in it. Because employees is a constant with the number 3 in it. I've got a scanner keyboard, and down here I've got sysout println enter the hours worked by employees. It's going to say enter the hours worked by 3 employees. Then I've got system out employee 1 hours 0 equals keyboard next int. And then sys out print employee 2 is hours 1 keyboard next int. So on that first bookshelf, which is bookshelf 0, we're going to basically type in a numeric value, and we're going to grab that from the keyboard next int and put it into that bookshelf. Down here in keyboard next int for the next one, on the bookshelf labeled number 1, we're going to put the employee 2 information in there. And then sys out print employee 3, we're going to basically grab the keyboard next int and put that into the bookshelf labeled number 2. Then we can come down here and say the hours you entered are sys out print ln hours 0 element, which is bookshelf 0, and we're going to print hours 1, which is what's in the next bookshelf, and hours 2, which is the next bookshelf. So if we go ahead and run this, so employee 1, we're going to type in 40. We hit the enter key. It says employee 2, they got 20 hours, and employee 3 got 15 hours. When I hit the enter key, look at that. The hours you entered are 40, 20, and 15. So an array basically holds data. So it's one variable that can hold a whole bunch of data behind it. So that's kind of nice. And what's, as we'll see in here a little bit, we can use loops to actually step through these arrays to get that information or even load the information. Now, one thing we have to be very, very careful of, and that's making sure that we do not go outside of our array. And we'll see some issues here with that in a second. Array demo 2, let's open up array demo 2, and this talks about what I just said, where we can actually utilize looping to get data into an array and how we can get data out of an array. So here I've got the final int employees equals 3, so that's no different. Here I create my array of hours, which are integers. There's going to be 3. So my bookshelf's going to have 3 shelves on it. I've got my scanner keyboard. I've got my enter hours worked by employee. Now down here, look at this. Now I'm going to use an array. And I'm going to say, remember there's 3 parts. The first part gets executed once at the beginning. The second part is the part that's going to check to see if we go into this loop. So while the index is less than employees, we're going to come into this loop. And at the end of every loop, we're going to add 1 to index. So we got our array of 3 employees. What I like to call my bookshelf. My bookshelf's got 3 bookshelves in it. I go through my loop where I'm going to say employee index plus 1, because again we don't want to say employee 0, we want to say employee 1, because remember, like I talked earlier, our bookshelves are numbered 0, 1, and 2. Well, we don't want to say employee 0, so we're going to say employee 1, because the first time through index is 0 plus 1. We're going to then have a colon, and that's what we're going to ask from our keyboard next int. We're going to grab that and throw that into the bookshelf 0 first time through. We come back around, index is going to have 1 in it, and then we're going to say enter employee 1 plus 1 is 2, and we're going to grab the next one, throw that into the next element of that array, and then we're going to do it one more time to get the third element. And then we're going to say the hours you entered are, and we're going to say int index 0, so we're going to do the same exact loop. And this time we're just going to say hours index. So we're going to grab, like I said, whenever we create an array, it's like an empty bookshelf. We put our bookshelves in there. Now we're going to go through each bookshelf. So bookshelf 0, we're going to grab where we typed in, bookshelf 1, and bookshelf 2. So if we run it again, I type in a 40, I type in my 20, I type in my 15, and it says the hours you entered are 40, 20, and 15. Now, the one thing that I said this just a few minutes ago is we need to make sure we stay within the boundaries of what an array can handle. And it says Java performs array bounds checking, which means that it does not allow a statement to use a subscript that is outside the range of valid subscripts for an array. So for example, if I've got an int values equals new int 10, so values is the name of my array. There's going to be 10 elements in there, or my bookshelf's going to have 10 bookshelves in it. And those bookshelves are going to be labeled 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, if I were to do something like what we're going to talk about right now, which is, what's the name of this? Yeah, it's the invalid subscript. So let's look at invalid subscript. So this one here, we've got an array called values. It's got 3 elements. So I'm going to come in here with my for loop. Again, the first part is executed at the very beginning, so we're going to have an index equal to 0. And I'm going to say index while the index is less than 4. Now what does that mean? Well, we're starting at 0, and this is going to basically bomb, or not bomb, it's going to stop the loop when the index is basically becomes 4. So that means we're going to go through this loop 0, 1, 2, and 3. How many elements are there in this array? 3. So we're going to basically go through this thing 4 times, so we should have an error. So when we run it, look at that. Exception in thread, index 3 out of bounds at line 18. Yep, right here, line 18. So basically that's where it basically blew up. And the reason it blew up is because it says index 3 out of range. Well, there is no index 3. All we have are 0, 1, and 2. So when I tried to go through this with number 3, it basically blew up. So if you ever see index out of range or out of bounds, that basically means you tried to go beyond what your array can handle. So again, think of that bookshelf. It's got 3 shelves, 0, 1, and 2, and I tried to go to the number 3 bookshelf, and there isn't one. So basically the program will blow up. So any questions so far? Awesome, awesome. Okay, so now it says on the bottom of 410, it says watch out for off by 1 errors. It says because array subscript starts 0 rather than 1, you have to be careful not to perform the off by 1 error. For example, we look at the following code. We've got a constant called size, and it's set to 100. We go ahead and create an array of numbers set to size. So those are going to be those bookshelves are going to be numbered 0 through 99. And when I come in here and I say for index 1, index while the index is less than or equal to size. Okay, what's equal to size? Equal to 100. So that's basically the same exact error that we got up here for this out of bounds exception 3. So what I really need this to say is less than size. Because if I say less than or equal to, it's going to go from 0 to 100. And basically that's 101 elements in an array, and we only have 100. So we have to be very, very careful of situations like that. We can initialize an array. So for example, I can do int, left right square bracket, days, so the name of my array is days, and I'm not telling it how many elements I have. I'm just going to say I want to load it. Now notice I've got an open brace and an ending brace, and I've got numbers, integers in this case, because this is an int, integers separated by commas. And if you notice, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this array will have 12 bookcases, and each bookcase will be loaded with a number. So let's see what that looks like. Let's open up array initialization. And again, there I have my int, left and right square bracket, days is equal to 3128. So you can see it's basically the days of the month. And then I can use my for loop. I'm going to initialize the index to 0. It's an integer. And while the index is less than 12, notice it doesn't say less than or equal to 12, we're going to go into this loop. And then at the end of every loop, we're going to add 1 to the index. So I go ahead and do sysout println month index plus 1. So it's going to basically say, instead of saying month 0, it's going to say month 1 has days index. So it's going to go to that bookshelf, grab whatever's on bookshelf 0 and display it. The next time through, it's going to grab bookshelf 1 and display it. Next time through is bookshelf 2, and then basically so on and so forth. So it's going to say month 1 has 31 days. Month 2 has 28 days. Month 3 has 31 days, and so on and so forth. So let's go ahead and run this. And voila, there you have it. Month 1 has 31 days. Month 2 has 28 days. Month 3 has 31 days. All the way down through month 12 has 31 days. So we can create an array. We can also create an array and initialize it and fill it with the data at the same time. Now, we can do this. We can say int. Again, this creates an empty array. Like remember, like I said in the beginning, it's an empty bookshelf. It basically has no shelves in it. It's got int numbers. I can also say int numbers and put the left and right square bracket over on this side. Those are basically going to create the same exact empty array. I can also say int left and right square bracket numbers, codes, and scores, and that's going to create 3 arrays, three integer arrays. Now, if I did it this way, if I did int numbers, left and right square bracket, and codes and scores, it only created 1 array and then 2 primitive data types. If I wanted to do it this way, I'd have to do int numbers, left and right square bracket, comma, codes, left and right square bracket, comma, scores, left and right square bracket. So this up here is the same as what's down here. As you can see, what we did up here is probably a lot easier just by putting the left and right square bracket on the data type and not putting it on each of the variable names. Okay, so how do we process array elements? Individual arrays elements are processed like any other type of variable. So I can actually do this. I could say gross pay is equal to hours number 3. So it's going to grab the value that's in the 3rd bookshelf. I should say not the 3rd, but the number 3 bookshelf. Because remember, it's a 0, 1, 2, 3. That'd actually be the 4th. So it's going to grab whatever value is in that number 3 bookshelf, multiply it times pay rate. So if I did int scores, and then I initialized it with 7, 8, 9, 10, 11, and I said plus plus score 2, so it's going to grab 0, 1, 2, it's going to grab 9 and add 1 to it. If I did score number 4 and plus plus, it's going to go 0, 1, 2, 3, 4, it's going to grab number 11 and add 1 to it. I could also do a minus minus to the actual count. So if I had a variable as my index, my subscript, I can actually do subscript minus minus, and that will basically grab 1 previous. I don't know if I would do that so much. We should probably process the subscripts, either by some type of a variable that we basically have in a loop situation, I would probably stay away from this type of incrementing or decrementing the index. So let's look at pay array. And here we have our public static void main. I've got three variables. One's a constant. The employee is set to 5. I've got double pay rate and double gross pay. I create an array of hours. They're integer data types, and they're going to be instantiated as new integer with employees. So we're basically created an array with 5 bookshelves. They're going to be numbered 0, 1, 2, 3, and 4. Here I got my scanner keyboard. And down here I do assist print ln into the hours worked by employees. That's going to say 5 employees who all earn the same hourly pay rate. So down here I've got a for loop. I got an index I set to 0 while the index is less than employee, which is 5. So while the index is less than 5, we're going to go into this loop. At the end of every loop, we're going to add 1 to the index. So I come in here, I want to say employee index plus 1, and we're going to say hours index. So we're basically saying we're going to load the hours, whatever the index is, that's the number bookshelf, so first time through it's number 0. We're going to basically grab whatever we typed in on the keyboard next int. We're going to do that until index is basically equal to or greater than employees. Once that happens, we're going to drop out of this loop. Now we're going to ask the user for the hourly pay rate for each employee. So we're going to basically then grab the keyboard next double and throw that into pay rate. Then we're going to calculate each employee's gross pay. So we're going to display here is each employee's gross pay. Then we're going to come into our for loop while the index we're going to set the index equal to 0. While index is less than employees, which is 5, we're going to come into this loop. At the end of every loop, we're going to add 1 to index. Gross pay is going to be equal to whatever is in hours for that subscript. Remember my bookshelf? So first time through, I'm going to grab the hours in bookshelf 0. I'm going to multiply that times pay rate. I'm going to throw that into gross pay, and then I'm going to print employee index plus 1, and then basically their gross pay. And I'm going to come back around and get the gross pay for the hours in that index 1 times pay rate and do the same thing. So we're going to do that for each employee. So when we run this, we're going to come down here. So employee 1, they worked 10 hours. The next one worked 20, 30, 40, and then 50 hours. They basically each made $10 an hour. So pretty easy. Employee 1 made $100, employee 2 made $200, $300, $400, and then $500. So I hope you're kind of understanding how we got this variable called hours, but it has multiple values that it holds. Again, just like a bookcase. I create my empty bookcase, and then I tell it how many shelves I want, and then each one of those are numbered, and then I can actually grab or put in to each bookshelf depending on what numeric value I'm using to grab that particular bookshelf number. Well, but the thing with objects, we create different objects from one class. This is basically one variable that holds a whole bunch of data. I kind of see where you're going at, where like I said, an object, so kind of like our rooms where we had the kitchen, the dining room, and then the den. Well, each one of those was a separate object, and each one of those had its own instance variables that held a specific value for the length and the width of that room. But each one was a separate, where this is kind of, they're similar in that aspect, but they're different because there was three different objects, where in this case there's just one variable. It just holds multiple pieces of data. Well, I like what you're saying. Okay, so up to this point, we've been declaring this constant called employees to basically kind of determine, and then we utilize that employees down here in our for loop. Well, guess what? We do have a parameter where we can actually get the length of an array. Okay. So let's say I create an array of doubles called temperatures, and we're going to instantiate as a new double where it's basically got 25 different elements, 25 bookcases, 0 through 24. Well, I can actually do this. If I have an integer variable called size, I can say size is equal to temperatures dot length. And it will tell me how many elements or how many bookshelves there are in that bookcase. So I can say for int I equals 0, so I create an integer I initialize to 0, while I is less than temperatures dot length. That's pretty cool. So now it's basically going to be set to 25 as the length. So while I is less than 25, we're going to come into this loop. At the end of the loop, we're going to add 1 to I, and then I'm going to print temperature I. So it's going to grab each bookshelf's temperature one at a time and display it. Now, this next one is called the enhanced loop. Now, the enhanced loop it's a for loop, but it's different in fact that we don't have to initialize the index to basically go into the loop. With this, we're going to use the array. The array is going to determine how many times we go through this loop. So for example, I've got 4, now let's not look at that. Here, let's look down here. So I've got int numbers, so it's an integer array. The name of the array is called numbers, and it's going to have 3, 6, and 9. So it's going to have 3 elements, 3 bookshelves. Now, instead of doing for int I equals 0, and while I is less than numbers dot length, I don't have to do that. I can just do this. I can do for int val colon numbers. Looks kind of weird, but here's what this does. It says this has to be an array, and while that's an array, I'm going to grab each element one at a time and throw it into val. So automatically, when I do my sysout print val, it's going to print the first element. Then it's going to print the next element, and it's going to print the next element, and it knows that all there are 3 elements that's going to automatically drop out of that loop. So pretty powerful. We don't have to know the length. We don't have to know anything. We don't have to do an I++ to basically go through this loop. This loop automatically says, I know there's 3 elements in this array right here. I'm going to throw them each one at a time in val. So then when I come down here and print val, it's going to print 3, it's going to print 6, and it's going to print 9. Exactly. Exactly. It knows how many elements there are. Okay, so so let's do this. This is not in the book, but it's called Pay Array Enhanced. So if we look, this is just like the pay, like the hours pay that we just worked on a few minutes ago, and it's called Public Class Pay Array Enhanced. We've got our final int employees equals 5. We've got our double pay rate and our double gross pay. I come in here, I've got int hours equals new int employees, so we basically create an array of hours. Just this is identical to the other one. I've got my standard keyboard, and I'm going to say enter the hours worked by, in this case, 5 employees who all earn the same hourly rate. I come down here and I've got my for loop. So there's my int index equals 0. So while the index, first time through it's 0, while index is less than 5, we're going to go into this loop. At the end of every loop, we're going to add 1 to index. So there's no differences so far. So it's going to basically ask for employee number 1, which is index 0. It's going to grab the keyboard next int. We're going to throw it into hours. Okay. So we load them all up. Now we're going to say enter the hourly pay rate for each employee. We do that. Now the next thing we're going to do is we're going to say here is each employee's gross pay. Now we create this index, we create this integer x and we initialize it to 1. And we'll see how we use that here in a second. But notice here's my enhanced for loop. It says for int hours, HRS, hours. So what it's going to do, it's going to grab each element from the hours array and throw it into this variable hours, one at a time. So when we come in here, it says gross pay equals hours times pay rate. And we go ahead and say employee X. That's where we're using this X at. So employee 1, $ gross pay. And then I do X plus plus. So next time through, it's going to say employee 2. We add 1 to X, employee 3, so on and so forth. So as you notice, we're not, when I'm using hours up here, I'm not using an index, I'm not using a subscript, I'm basically just saying hours, because the enhanced for loop just grabs each element one at a time and throws it into this variable hours. So every time it executes line 43, it's executing the next element in the array, the next element array, next element array, until there are no more elements, then it drops out of the for loop. So if we run this, and let's do the same thing, we'll do 10, 20, 30, 40, and then 50, and we'll do the hourly rate, we'll do 10 again, hit the enter key, and it says, here is each employee's gross pay, employee 1, 100, 200, 300, 400, 500. Now, the one thing we have to basically know about a for loop and an enhanced for loop. It says if you need to change the contents of an array element, you cannot use an enhanced for loop. If you need to work through the array elements in reverse order, you cannot use an enhanced for loop. If you need to access some of the array elements but not all of them, you can't use an enhanced for loop. If you need to simultaneously work with 2 or more arrays within the loop, you cannot use an enhanced for loop. If you need to refer to the subscript number of a particular element, you cannot use an enhanced for loop. So, like it says right here, if any of these circumstances basically occur, you cannot use the traditional, or you have to use the traditional for loop to process the array. So kind of like back here with the employee number, with our pay array, notice that we said employee # index plus 1. Well, since we're using a for loop, there was no index, so we had to fudge that by doing the x, initializing x equals 1 and then adding 1 to x each time, because there was no index for us to basically utilize. So if you do need to use the index like we did here, then probably a traditional for loop is what we should have used. So any questions on that? So Letting the user specify an array size. Java allows you to use an integer variable to specify an array's size declarator. This makes it possible so that when we use code listing 7.6 demonstrates this. So let's take a look at the display test scores. So come over here and click on display test scores, and here I've got public static void main. I've got int num tests, and here I create my empty array. Okay, it's an empty bookshelf, has no shelves in it. So it's got int tests, and the left and right square bracket says it's an array. We don't know how many bookshelves to put in here yet. So I create my scanner keyboard, and then I come over here and say, how many tests do you have? Num tests is equal to keyboard next int. So we get that from the user. This is where we then set the number of bookshelves in our bookcase. So test is equal to new int num tests. So on line 24 is where we set the number of elements in our array, or number of bookshelves in our bookcase. Then I'm going to come in here and say for int index equals 0, so that gets executed at the beginning, and while index is less than test.length. So whatever we typed in, it's going to go just up to that. So if I typed in 5, it's going to say while index is less than 5, we're going to go into this loop. Then we enter test score, again index plus 1, and then we basically put a colon, and then we get that from our user from our keyboard next int. So test index, the first time in it's a 0, next time in it's a 1, 2, 3, and then whatever we typed in up here for number of tests. And then we come out here and we say, here are the scores you entered for int index test.length. Now, you know what? They should have probably done a enhanced for loop right here. That would have been a perfect place for it. We should have said, you don't have to do this, but I'm going to do a for. Test is an int, okay. So int tst colon tests. And so what that's going to do is it's going to grab each up. But notice what happened there. Yeah, see, that's where I didn't count on it. They're using the test index to basically display what test score we're basically dealing with. So I notice it's doing a print. So it's going to do test score space, test score space, test score space. So oh no. I can still utilize this. My bad. I can still utilize this. There we go. My bad. I was thinking they were saying test 1, test 2, test 3. No. So here's an enhanced for loop. If you notice, it's a lot less code. So now let's run it. And it says how many tests do we have? Let's type in 5. First test score is 72, then 85, then 81, 94, and 99. Hit the enter key, and it says here are the scores you entered. 72 space 85 space 81 space 94 space 99. Any questions on that? Okay. Now, the one thing we cannot do with an array, I cannot change the number of bookshelves in my bookcase. Once I set them to a number of bookshelves, they are stuck at that. So if I were to say int numbers, left and right square bracket there, it says it's an array, is instantiated as a new int 10. If I came in here and say numbers equals new int 5, it would basically blow up on us. It would not work because we've already established the number of elements in our array. It cannot change. So for example, if I were to try to do something like this and say tests equal new int 4, not parentheses, watch what happens when I try to run it. Did that work? That didn't work, did it? Oh, numeric values. Wow, it did I know why. We hadn't put anything in there yet. So let me do this. Let me move this. That's why. So let me back up what I just said. Once we set the bookshelves, we can change them if nothing has been put in them. So we can truncate or add more to it. So let me do this. I'm going to actually move this down here. Okay, now let's see if it works. It kind of, yeah. It did work, but here's what it did. It created a new array on line 33 of 4 bookshelves. Shh. So it basically created,
They're my bulbs. Stop it. What are you doing? You're opening.
sorry about that. So anyway, so here's what it did. It didn't blow up like I thought it should, but what it did is it basically created an array called tests, initialized it to 4, and it basically set each one of those elements to 0. So, yes, that's kind of what it does in the real world. So whenever we create a primitive data type, um, it kind of sets it to 0, but it kind of doesn't. Here's what I mean by that. Is it sets it to 0, but not a real 0. And what I mean by that is, so if I created an array called, I'm sorry, if I created a variable called total, and I didn't initialize it to 0, and I tried to add to it, it won't let me do any addition. But if I display it, it'll display a 0, just like it does here in this element, this array. So you see what I mean? It's kind of weird in that sense that it won't let me add to it, but if I display it, it'll display a 0, which is kind of, doesn't make sense, but that's how the compiler works. So the thing we do not want to do is basically change the number of bookshelves or elements in our array, because it will wipe out everything. It'll wipe out all the bookshelves and then put all new shelves in and then initialize everything to 0. Now, I think down here on the bottom of Yeah, we already talked about that. Okay. So, yeah, so basically that's exactly what happened. So we had our 10 element array, we loaded it with numbers, and then I basically recreated it with only 5. Well, it created a brand new 5 element array is exactly what it did. Okay, now let's talk about copying an array. So let's say I've got an array called array1. It's an integer array, and I initialize it to 2, 4, 6, 8, 10, which is basically 1, 2, 3, 4, 5 elements in that array. And then I say int array2 is equal to array1. This does not copy the array. Here's what it does. Is we now have this array, it now has 2 name tags. It's got a name tag called array1 and another name tag called array2. If I change anything in array1, guess what? I'm also changing array2 because that array has 2 of the same name tag. So here I am. I'm an array. I hold 5 elements. I'm called array1, and then I turn around and say array2 is equal to array1. I now have 2 name tags on me. I've got 2, 4, 6, 8, 10 inside of me. If I go through array2 and say change the 3rd element, which is number 6, I change it to a 7, and then I go to array1, I say show me element number 2, 0, 1, 2, it's going to show number 7. So let's see how that looks. Let's look at samearray.java. So here I've got my array 1 set to 2, 4, 6, 8, 10, and here's array 2 that's equal to array 1. Guess what? Array 2 and array 1 are the same exact array, and we'll see what we'll see what I mean by that. So I'm going to change array 1 element 0, which is 2, to 200. I'm going to change array 2 number 4, which is 0, 1, 2, 3, 4, number 10, to 1000. Then I'm going to show the contents of array 1. I'm going to go through, I'm using an enhanced for loop. I'm going to basically take array 1, one element at a time, and put it into value. I'm going to print, all on the line, value plus a space. You know, this is a print, not a print ln. And at the end, I do a print ln just to basically go down a line. And then I'm going to show the contents of array 2, and same thing there. It's going to grab each element from array 2 and put it into value. And then I print value plus a space, and then I do a print ln at the end to go down a line. So when we look at this, here's the contents of array 1, 200, 4, 6, 8, 1000. Contents of array 2, 200, 4, 6, 8, 1000. So up here I was expecting array 1, the first element, to be changed to 200, not array 2. And then array 2, I was expecting that to change to 1000, but not for array 1. But since I just said array 2 is equal to array 1, they are the same exact array. So whatever I change in array 1 is also the same for array 2. Does that make sense? They're the same array. Just that's basically what this is showing right here. When I said array 2 is equal to array 1, they're both pointing to the same address in memory. That's all we do. That's all it did there. So whatever I changed array 2, I'm changing this array right here. Whatever I changed to array 1, I'm changing that same array, because they both point to the same exact place in memory. You can't say array 2 is equal to another array. You can't say one array is equal to another, because it's basically just going to be pointing to the same place in the address and memory. Now, if you want to copy an array, we'll see an example of that in a little bit. We actually can do a copy, but it's pretty manual. It's very manual. Um, yeah, and here's how we would do it right here. So I'm going to have first array is equal to 5, 10, 15, 20, 25. So it's got 5 elements. I'm going to say int second array is equal to new int 5. So second array is empty right now. It's got 5 bookshelves, but it's completely separate in memory than our first array. Because they're two, since I created them separately, one's here in memory, one's here in memory. Then I come down here and I create a for loop. Index equals 0, while the index is less than first array dot length, I say second array index is equal to first array index. So you see what we're doing? We're taking each element for first array and copying and pasting it into that element of the second array. So it's going to go through one at a time and copy what's in the 0 bookcase of number 1 and put it into array number 2. It's going to grab the number 1 bookshelf and copy it to the number 1 of the other bookshelf. So it's copying each element one at a time and placing the other. So now when this for loop gets through, first array and second array will basically look identical. They'll both have 5, 10, 15, 20, and 25. Yeah, yes and no. I mean, when you say slow doing that, yeah, in computer times that could be if it was a very, if it had thousands of elements in the array. But as far as computer time, when we're talking nanoseconds, probably not. Now, if they were string objects, now we'll see later on, we can create an array of objects. That could take some time if those objects have a lot of stuff in them. So let's talk about passing an array as an argument to a method. Since an array can be passed as an argument to a method, to pass an array, you must pass the value in the variable that references the array. So let's look at pass elements. Now, an array is not really an object. An array is basically a container. Again, I've had students say it's like an egg carton. When you create an array, it's an egg carton, and each place where an egg goes is numbered. So when I basically want to put something in the number 2 slot, I basically say that egg carton name number 2, and it will go in that number 2 slot. So with an egg carton, it's got 0 through 12 or 0 through 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 different spaces in that carton, and each one has its own number. So so think of an array as that. An array is just this container that can hold multiple things at one time. Yep. Okay. So here's pass elements. We've got our int, left and right square brackets, numbers. So I got a numbers array, and it's got 5, 10, 15, 20, 25, 30, 35, 40. So 1, 2, 3, 4, 5, 6, 7, 8 elements in this array, or 8 bookshelves in this bookcase. So I'm going to go through this one at a time. I'm going to say index equals 0, int index equals 0. While the index is less than numbers.length, so while index is less than 8, we're going to go into this loop. At the end of the loop, at the end of every loop, we're going to add 1 to the index. And it says show value numbers index. So this is the show value. This is a method down here. We're going to pass each element one at a time, and it's going to be received as an int n. We're not passing the array. We can pass the array, but we are just passing one element down here one at a time. And down here I do a sysout print n plus a space. Notice this is a print, not a print ln. So it's going to print across. So it's going to go through, every time it grabs an element, it calls this, prints it, calls it, prints that in a space, and it's going to do that until it's basically done. So it's going to basically call this show value 8 times. So when we run it, there it is. Now if we wanted to see how this looked as we were running it, we could see that if we debugged it. So I'm going to debug it. So here we are at line 24. We've got N5 because N was passed to this, which is the first element. We print it, it prints a 5. We come back up to the for loop. We call the show value. We're going to grab, so here's numbers. Look, let's take a look at numbers. I expand numbers. Look at element 0 is a 5. Element 1 is a 10. 2 is a 15. All the way through 7 is 40. So there's 8 elements, 0 through 7. So we're going to grab, what's the index right now? Index is a 1. So it's going to grab the 1 index, which is a 10, and pass it down here to show value. So come down here to show value. N is a 10. Whoop, I hit run. Damn it. I hit run. Well, anyways, you kind of get the gist of what's going on there. So basically grab each one of these elements one at a time and pass it down to show value. Now, what about passing an array as an argument? So so just like our other variables, it grabs the address and passes it down here, but down here it basically creates a new array and it basically copies that array basically. So let's take a look at pass array. So here's our public static void main. We've got our constant called array size equal 4. And I've got int numbers equals new int array size. So we create an array called numbers, and we basically are going to make it have 4 elements in it. I call get values. I'm going to pass numbers down to it. So I come down here, and you know what? The way this is going to work, I think it actually does pass the address down here. I'll explain what I mean by that here in a second. So we got our scanner keyboard. We then say println, enter a series of array length numbers. So it's going to tell us the length of that array numbers, which is 4. So it's going to say enter a series of 4 numbers. And we got our for loop, and index 0, while index is less than 4, the array.length, we're going to come to this loop. So enter index plus 1, so enter 1. And then we're going to say array index, the name of the array we passed down here, keyboard next int. So then when we come back up here, I'm going to say show array numbers. So it looks like we are truly passing the address of the array. We're not passing the array and then making a copy of it like we do with variables. So that's a little different. And that makes sense because we could have an array of thousands of numbers in it, and that would be really way too much to try to make a copy. So the address is better. It's better at just passing the address to that method and utilizing it that way. That makes more sense. Okay, so now when we come back, this numbers has been loaded, and then it says here are the numbers you entered, and we're going to call show array and pass the same array down here to show array. So we receive it as int, left and right square bracket array, and then we go through the for loop. So we set the index equals 0. While index is less than array.length, which is 4, we're going to come to this loop, and we're just going to print array index plus, so it's basically a print, not a print ln. So again, it's going to print across, and it's going to basically say each element with a space. So we go through this. So we go through this, and it's so we enter. Oh, let's just type in some numbers. Just make some up. So here's the numbers you entered. So let me step through this. So I'm going to basically break right up here on get values. I'm going to put a breakpoint right there. And then I'm going to debug it. Okay, where are we at? Step through it. We're still over here on this one. What the heck? Let me stop to run. What's that? That's really helpful. So pass array, I'm going to do a right click and say debug as a Java application. And there we go. Now we're running the right one. So we look over here. Here's our numbers. So I've got 0, 1, 2, 3, and 4, and all they got zeros in them. I'm going to basically call the get values. So I step into it, and notice that inside of this get values, we're now inside this for loop. And right now it's got 0, 1, 2, 3, 4, again, all zeros. So I type in some numbers. That was weird, wasn't it? Down here it didn't show anything in the numbers, but up here it does. Okay, so there's those sets of numbers. So come down here, now I go to show array. Oh, I don't know what I did. I clicked on something wrong there. But anyways, so then it went down to show array and showed the 22, 33, 44, 55. But what was really strange is, I'm going to run this again, is up here, it's got all zeros in it. When it basically passes down here, and I enter number 1, I'm expecting this to show 2, 2 in it, but it doesn't. And 3, 3, 4, 4. Now once I hit the enter key, because this get values, it's actually loading the array one at a time on 48 right here. Now when I hit the enter key, now they all have data in them. I wonder if it doesn't do it until the loop is over. That must be what is happening. It doesn't display those numbers as being entered until the loop is over. That must be. Yeah, that could be. That could be. So now let me. Oh, you know what I needed? I needed to do this. Yeah, I know what I did wrong. I got to do a step into to go into it. That's right. I think that's where I screwed up. That's why it didn't show. Let me show you what I mean. So stop the run, click debug. So to go into get values, I actually have to click on step into. Now it goes into there. Okay. So if I take a look at the array, there's my array now, and now it's going to do what I want it to do. So when I click on here, enter a series of 4 numbers, and now it's going to step through that array one at a time. So enter 1. See, now it's got a 22. Now it's doing what I'm expecting it to do. Now I type in my 33. Now there's a 33 on there. Okay. Yeah. So now we go back to here, and now when I go to show array, I have to click the step into. It has this, because if I step over, it just steps over line 25 and executes line 25. If I want to go into that method, I have to click on step into. Now inside here, now I can see it execute this one number at a time. And now it's over. Okay. That's what I was expecting. So any questions on passing the array? So what I told you earlier was wrong, is it actually passes the address of the array and it utilizes that array. It's actually, so when whatever I modify in where it's passed to is actually augmenting that array and getting data from that same array. Yeah. So, some useful array algorithms and operations comparing arrays. So, when we use the equal operator with reference variables, including those that reference arrays, the operator compares the memory address of the variables, what the variables contain, not the contents of the objects referenced. Because two array variables in this code reference different objects in memory, they will contain different addresses. So therefore, we cannot do first array equals second array. It's always going to be false because the address is different. If we want to see if they equal, do I have an example? Yeah. Let's look at compare arrays. So here we have our public static void main. We've got first array is 246810 and second array is 246810. So they're identical in content, but they're not identical because they're in two different addresses in memory. So I'm going to create a Boolean array1 equals true. I'm going to set my index equals 0. I'm going to create an index, an integer index, and set it to 0. I'm going to say if first array dot length is not equal to second array dot length, I'm going to say arrays equals false. So what that's saying is, if array 1 has 5 elements and array 2 has 3 elements, right off the bat they're not going to equal because they don't have the same amount of elements in the array. So if that's true, it's going to set array equals false, and then it won't even go into this loop down here. But if it is false, then we're going to go in over, when we get to this while loop, it's going to say while arrays equal, because remember we set it to true up here, so while arrays equal is equal true, and index is less than first array dot length. So index right now is 0, and it's less than first array dot length. If first array index is not equal to second array index, what we're looking at is we're looking at element 0. If element 0 for the first array number 2 is not equal to the first array element of array 2 or second array, and that again is 2. So if they aren't equal, we're going to set arrays equals false. Well, First time through, 2 does equal 2, so it's going to basically not, it's not going to do anything. And then we add 1 to the index. We come back up here. Index is now 1. Is 1 less than the length of the array? Yep, because the length of the array is 5. We're going to come here and do the same thing. If the number 1 element in the first array is equal to the, or not equal to the first number 1 element of the second array, we're going to set arrays equal false. So what we're doing is we're basically going to, we've got arrays equal set to true. Anytime it gets set to false, when we come out of this while loop, we're going to say, if arrays equal, if it's true, we're going to print the arrays equal. Else, we're going to print the arrays are not equal. Now here's kind of the bad, well, no, not the bad, no, that's, I was going to say, the bad thing was about this while loop is I guess if that's equal to false, it won't even go into the while loop, which is what we do want. Yeah. So that's good. So if line 12 is true, it's going to set arrays equal false. It won't even go into the while loop. Okay, so let's run it. And it says the arrays are equal. But if I change this one right here to an 11, and I run it again, it says the arrays are not equal. Because it compared the first elements, they equal. The second elements, they equal. The third elements, they equal. The fourth elements, they equal. But the fifth elements do not equal. And it basically will drop out. Now here's what's really nice. If I change the first one to a 3, so the first time, so line 12 is not going to be true, so it's not going to set that to false. But on line 16, as soon as we come into this while loop on 17, it's the very first thing is it's going to check the first elements, and they're not going to equal, so it's going to set arrays equal false, which guess what happens? That causes it to drop out of the loop. So we don't have to go through the entire loop, because once we get a not equals, boom, it basically drops out of that while loop. And it's going to display the arrays are not equal. So when I run it, it says the arrays are not equal.
Oh, yeah. I'm going to watch it tomorrow.
So, okay. So any questions on that? So the thing you got to remember is if you want to compare two arrays, you've got to do it manually. There's no easy way to compare the two. I can't just say does first array equal second array? And that's never going to happen because the address is in there as well, and since they have two different addresses in memory, they'll never equal. Exactly. Yeah. Right. Well, it will try to compare the content as well, but part of the array is the address, so that part will never equal, so that will cause the whole thing not to equal. Okay, how do we sum the values in a numeric array? To sum the values in an array, you must loop through the accumulator variable. So, pretty simple. We would just do something like this, where I would basically say int total equals 0 for int index equals 0, while the index is less than the units.length, number of items in that array. We would just say total plus equal units index. It's going to grab each element one at a time and add it to total. Getting the average of the values in a numeric array, same exact thing. We would go through and total them, and once we got the total, then we would just divide by scores.length. So the length is going to say the number of elements in that array. Finding the highest and lowest in the array. is we would basically do this. We would basically, so let's say I've got an array of 50 numbers, or 50 elements, I should say. So this numbers has 50 bookshelves. I'm going to say int highest equals numbers 0. So what that says is grab the very first element and throw it into this variable called highest. Then I'm going to go through this array one at a time, except I want you to look at this. We're starting at index 1. Why? Because we've already got 0. We grab the 0 element and put it into highest. So we're going to start with the second element. We're setting the index equals 1. While the index is less than the length of the array, we're going to go into this loop. And it says if numbers index is greater than highest, so if it's greater than this variable highest, then we're going to set highest equal to that element of the array. So when this for loop gets done, highest will have the highest value in that array. Does that make sense? And vice versa, we could do lowest. So we grab the very first element of the array, we throw it into lowest. Same thing, we start at index 1, start the second element, and while the index is less than the length of the array, if the numbers index, so each element of the array, if it's less than lowest, then we're going to make lowest equal to that element of the array. And when we get done, lowest will show, or will contain the lowest number in that array. So let's take a look at sales data. And I think we're going to see a lot of this, what we just talked about in here. So this class keeps the sales figures for the number of days in an array and provides methods for getting the total and average sales and the highest and lowest amount of sales. So right here I've got private, double, left and right square bracket, sales. So I created an empty array. It has no bookshelves, has no elements. So before I can use this array sales, I got to say how many elements it's going to hold. So here I've got my public sales data. So this is a class. This is going to be a class. So it looks like private double sale. This is my instance variable. I'm going to have an array as my instance variable. So here's my public sales. So note says sales data, and here's sales data. Here's my constructor. So my constructor is going to receive an array. And what we're going to do is we're going to create a new array called sales, or I shouldn't say we're not going to create, it's already up here. So we're going to say our array is going to be equal to new double s dot length. So whatever this array comes in here, the number of elements in the array, we're going to set the number of elements for this array to be the same. So if this s comes in with 5 elements, we're going to set sales, our array up here, to 5 elements. Then what we're going to do is a copy. We're going to go through this in a for loop. So set the index equal to 0, and while index is less than the number of elements in the array s, we're going to say sales index is equal to s index. So we're going to grab each element from this array s and copy it to sales. So when this for loop gets done, everything that is in the s array will now be in the sales array. Okay? So that's all the constructor is doing. The constructor is expecting, well, let me see, are there any other constructors? No. So when we instantiate this class, it's expecting an array to be passed in as the constructor. Now the question that should be asked is, why are we doing a copy of the array? And the reason we're doing a copy of the array, as we just saw previously, when I pass this array to this class, it's passing the address. So that means that array could be changed outside. So the calling class that calls sales data, and it passes the address of an array, that class can also modify this array S. And we don't want that. Whatever our instance variables we have in here, we want to control within our class. So that's why we copy everything from the S array to sales. So now if that other class modifies this S array, we don't care. We have everything copied here, and now we control how that data is accessed. So we have a get total, which creates a local variable called total. It's a double, and it's set to 0.0. And then this is where we basically then go in and grab each element from the array and add it to total. And when we get done, it's going to return total, because notice it's got a double up here. So whoever calls total is expecting something back. Now we got get average. Now this is pretty slick if you look at it. It says return get total, left and right parentheses, divided by sales.length. So what it does is this get average, let me scroll this down a little bit. This get average says get total. So it calls get total, which returns a double, which returns the total of everything that was basically totaled up that array, and then it divides by sales.length, the number of elements in the array, and that's the average. So that's pretty slick. One line of code gets the total, it then divides by the number of elements in the array, and now we have the average. And it's going to return a double as well. And then we've got get highest. So we create a local variable called highest, and it's equal to the very first element of the sales array. And then we go through this one at a time. We're going to start at the number one element, which is the second element. And we're going to basically do it while the index is less than the number of elements in the array. And again, if whatever's in that element is greater than highest, we're going to make highest equal to that element. When we get done, we're going to return the highest, which is a double. So we're going to know the highest number in that array. That same thing with get lowest. It's just like get highest, except we're looking to see, is the sales index, is that element less than lowest? If it is, we're going to make lowest equal to that element. And when we return lowest, it's going to return the lowest value of that array. And that's all there is. So let's take a look at sales, and this is our public static void main. We've got a constant called 1 week, and it's set to 7. We create our double array. It's sales, and it's equal to a new double 1 week. So basically it's going to have 7 elements, 7 bookshelves in this bookcase. We're going to call get values, and we're going to pass the array to get values. So we come down here to get values. Here we are receiving the array. Again, we're receiving the address, and when we modify this array, it's actually modifying the array in the previous call. So we got our string input. We're going to go through this for loop, and we're going to create an I integer set to 0, and while I is less than the length of the array, number of elements in the array, we're going to come into this loop. We're going to use a JOption pane. So it's enter the sales for day I plus 1. Again, we don't want to say day 0. We want to say day 1, day 2, day 3, day 4, day 5, day 6, day 7. And then we're going to say array I, so here's the array that we're calling it, is equal to double parse double, because remember, what we get from a JOption pane is a string. We have to convert it to a double and then put it to that element of the array. So when we get done with get values, we now have values from our user for 7 days of sales. So once we execute line 21, our array now has data in it. Now we create our sales data object called week, and we instantiate it as a new sales data, and notice we're passing the array sales to it. I want to create a decimal format object called $. So that there we have, it's going to round to 2 decimal places and use a 1,000 separator, or comma, 1,000 separator. Then I'm going to have a J option pane. I'm going to call the show message dialog. I'm going to say the total sales word $, $.format week.getTotal. So it's going to call the get total and show us the total sales. And then it's going to go to a new line and say $.format week.getAverage, and it's going to then call the getAverage method. Then it's going to show the highest sales were. It's going to call the getHighest. It's going to the lowest sales were, and it's going to get lowest. And then again, system exit 0, because we have a J option pane. We want to make sure that that process is completely closed. Okay, so let's run it. Oop. Shoot, I hate that. There it is. So sales for day 1. Let's go ahead and type, let's just do it easily. We're going to do 1,000. 2,000 for day 2. 3,000 for day 3. 4,000 for day 4. 5,000 for day 5. 6,000 for day 6. And 7,000 for day 7. So the total sales were 28,000. The average sales were 4,000. The highest sales were 7,000. The lowest sales were 1,000. I noticed that it basically rounded to 2 decimal places, and we do have our 1,000 or comma 1,000 separator. So, pretty cool stuff. You think so? Okay, so this next one is these in the spotlights, and it says Dr. LeClaire has given you a set of exams during the semester in their chemistry class. At the end of the semester, she drops one of each student's lowest test scores before averaging the test scores. She's asked you to write a program that will read the student's test scores as input and then calculate the average and lowest scores dropped. So what they're doing is we're going to drop the lowest score and then average the rest. Okay? So, our UML, we basically said, okay, we're going to have a class called grader. It's going to have test scores as an array, a double. Can notice the left and right square brackets. Those basically show this as an array. So test score is our instance variable. It's an array of doubles. We have a grader constructor where we're going to bring in the score array as a double, and again we can see that it's an array. We've got get lowest score and get average, and they're both going to return doubles. So let's take a look at grader. So here's our class grader. Here's our instance variable called private double, and notice that it is an array. And it's called test scores. So right now it's an empty array. It has no elements in it at all. Here's my constructor. It's expecting an array to be brought in. It's going to say test score is equal to score array. Don't know if I like that or not, but we'll just keep it just the same. Because remember, test score and score array are now pointing to the same array. They're not pointing to 2 separate arrays. They're pointing to the same array. The reason I don't like this is the class that it's calling this can actually change the score array in their class and it will change whatever we have on our test scores over here as well. So I don't know why they did this. I would have done the same thing as we did in the previous example and did a copy element by element to the test scores. Okay, so when we get done with this constant or a constructor, we will have test scores as an array. And realize test scores and score array are pointed to the same exact array. They are the same array. We've got get lowest score. I'm not going to go through this because this is pretty much the same thing as we saw in the previous. And then we've got get average. Now, since we don't have a get total, we are going to have to do a get total and then divide by the number of elements. So in here we got test score dot length less than 2. If the test score dot length, if there's only 2 test scores, we can't drop it. So we're going to basically say the average is 0. But if it's greater than 2, then we're going to come in and go through our for loop. We're going to use an enhanced for loop. We're going to take test scores one element at a time and put it into score, where we take score and add it to total. Then we're going to say lowest is equal to get lowest score. So come down, where's get lowest score? Oh, up here. Okay. So it's going to get lowest. So we're going to say total minus equal lowest. So we're going to subtract 1 from total. So that's where we drop our lowest score. And then we're going to say average is equal to total divided by test score dot length minus 1. Now, why are we doing this minus 1? It was because since we dropped the lowest score, we don't want it. So if we have 4 tests and we drop 1, we only want to divide by 3 and not 4. So that's why we're doing a minus 1. So we divide by we don't include that drop test score. And then we return the average. So let's take a look at the calling program, which is the calc average. So here's our public static void main. I've got int num scores. So here's my local variable. Here's my scanner keyboard. This is how many test scores do you have. We type in something in our keyboard next int. We put that in the num scores. We then create our array of doubles called scores, and we're going to use that num scores to set how many elements there are in that array. Then we're going to go through a for loop, and we're going to basically create an index equals 0. Well, index is less than num scores. We're going to come to this loop. It says system out print. Now this is a print, not a println. Enter score 1, or enter score £, and then index plus 1, because we want to start with the number 1, not 0. And then we're going to say keyboard next double and put that into that element of the scores array. So when we get done with this for loop, we will have our array full of test scores. Then we create a grader object called myGrader, and we instantiate it as a new grader, and we pass the array to it. And then we go ahead and print your adjusted average score is myGrader.getAverage. And then it says print your lowest test score was myGrader.getLowest test score, or just lowest score, sorry. So pretty simple. Let's type in, let's go ahead and run this. And how many test scores do we have? Let's go ahead and type in 4. And our first test score was 100. Our next test score was 78. Our next test score was 89. Our last test score was 90. We come in here, it says our adjusted average is 93. Our lowest test score was 78.0. So that average was off of 100, 89, and 90. Okay, any questions? Yep. It calculates the average on 3 test scores, not 4, because we dropped that the lowest test score. This next section talks about dealing with partially filled arrays. So let's say I've got this final int array size equals 0, and I go ahead and create an array of 100 elements. So it's going to have elements of 0 through 99. And I've got int count equals 0. Here's my scanner keyboard. It says enter a number or -1 to quit. So I basically grab my number, and it says while number is not equal -1 and count is less than the array.length, we're going to come in here and say array count. So count is 0, and it's equal to whatever the number is. We add 1 to count, and then we ask for enter a number -1 to quit. And we grab that number from the keyboard next to it, put it in the number. So if at any time we typed in a -1, it's going to drop out of this loop, which means we did not totally fill that array. So now, each iteration of this Sentinel controlled loop allows the user to enter a number to store in the array or -1 to quit. The count variable, so basically when they enter a -1 or it reaches the size of the array, it's going to stop. Now if I come in here and say I want to display it, notice I'm using count here. Now what is count right now? Count is not 99. If I stopped at 50, count now has 50 in it. So this for loop's only going to go from 0 to 49. Would it error if I tried to display it? I don't know. Like I said earlier, it looks like it initializes to 0, but it's probably a null value, and it would probably blow up trying to display anything else. So the whole point of this is to be aware if you only have a partially filled array, you've got to make sure you deal with it correctly. Saving contents of an array to a file is straightforward. We use a loop to step through each element of the array while writing the contents to a file. So let's say we've got this numbers here, and it's got 10, 20, 30, 40, and 50 in it. Well, I would just step through the array one element at a time. For example, I create my print writer output file as the new print writer values.txt. I would basically go through this array one element at a time, and I would say output file, println numbers index. So it's going to grab each index one at a time, or each element one at a time, and write it to that file. Yeah, and that's all that's doing there as well. It's used. In fact, this guy uses a for loop. This guy down here is basically using a while loop, but they're pretty much going to get the same results. Okay, how about we return an array from a method? So in addition to accepting arrays as arguments, methods can also return an array. So here I've got public static double get array. So look at this. So here's my get array method. It's going to return a double array. Look at that, double left and right square brackets. And it says double array, so here's my array, and it's equal to 1.2, 2.3, 4.5, 6.7, 8.9. We return the array. So this is going to return that double left and right square bracket. So let's look at the return array program. So here's my public class return array. It's a public static void main. Here I've got double left and right square bracket values. Here I have my empty array. It has no elements in it, no bookshelves. Values is equal to get array. So I come down here to get array. Now notice values is a double array. So notice this is a double array. So it's expecting an array of doubles to be returned. And what it does, we create an array. It's called array. It's going to be a double array. And again, there's that 1.2, 2.3, all the way through 8.9. And then we just say return array. So when we get done, values now has those 5 elements. And then I can use an enhanced for loop to say values. It's going to grab each element one at a time and put it into num. I can say, this is a print, it's going to print the num plus a space each time it iterates. So when we run it, there's 1.2, 2.3, 4.5, 6.7, 8.9, and there's a space after each one. Looks like there's 2 spaces. How did it get? Oh, is there 2 spaces there? Oh yeah, there's 2 spaces there. Okay. Now, just like the other one, this array and this values are basically pointing to the same exact array. Because again, we're passing back the address. There is a way to see that, see the memory address of that array, but gosh, my memory, it's been so long since I've done that. Let's see if we can get that. I'm going to basically click right here and toggle, and I'm going to step over it. So here's values. Well, it's got an ID 23, and I think there's a way you can look that up. Yeah. Yeah, there's somewhere in here. Where's the value? Here's name and value. Yeah, one of these things we can actually add. Yeah, like I said, I don't remember right off the top of my head, but one of these things we can actually get all that information. There's a way to get the addresses, the hashtags, and all that. Yeah, no, there's a way. I just don't know right off the top of my head. Okay, that's kind of where we want to stop for the evening. Are there any questions? Okay, so we're going to finish up chapter 7, and the next section we're going to cover is this thing. So we've covered everything from basically primitive data types for arrays. So now let's talk about string arrays. Now again, strings are basically objects. So, but we're pretty much going to be dealing with the textual part of it. So it says an array of string objects may be created, but if an array is uninitialized, each string in the array must be created individually. So what that means is if we don't initialize each one of the elements inside of an array, each one of those elements will default to a null value. So in order for us to utilize it, we will have to make sure they are initialized somehow. So we can do this. I could say string left and right square bracket names equals, and then we're going to basically create a 4-element array. And so this array called names is going to be a string data type. Do you have it up? And this array has 4 elements in it. Now, what gets stored in a string array are the addresses of those objects. And so the address at name 0, the first position, remember, talked about bookshelves, the very first bookshelf is going to have Bill in it, and the next one's going to have Susan, so on and so forth. So let's look at month days. So we go in here into chapter 7, and we'll see month days. And this is pretty much just like that previous example we had where we just had the days of the month. Well, now we basically have two arrays. Now these are what are called parallel arrays, meaning that each element at that particular index is going to be associated to the element of the other array at that index. So the very first item for this particular, this is a string array, and it's going to have all 12 months in it. And then we have another int, it's an integer data type days, and it's got 12 numbers in it. So the very first element of this array will be basically corresponds to the first element of this one, the second one corresponds to the second one, and so on and so forth. So we're going to go through a for loop, and we're just going to basically create an index, an integer index, set it to 0 while the index is less than months.length. Again, that's going to be 12. While it's less than that, we're going to come into this loop. Again, at the end of every loop, we're going to add 1 to index. And we're going to print months index, first time through it's a 0, has days index, so the same exact index for days in it. And pretty simple when we run it. There it is. January has 31 days, February has 28 days, so on and so forth. So, string array, we load it up with text and basically textual objects, and in this case it's just text literals in there. So string array is really no different than any other array. It's just basically, it's still a bookcase. We got shelves in it. Each shelf is numbered, and we can take and put anything in that shelf that we need to. So what we have is we've got this thing called months, and it holds a whole lot of data. We got this days, and it holds a whole lot of data. So calling string methods from an array element. So as recall from chapter 2, the string objects have several methods. So when we create a string object, it's got like the dot equals, all that type of thing. So, and one of the things it has is char at. So another one is 2 uppercase, a 2 lowercase. So these are built-in methods to the string object where we can utilize those for each one of the string elements in the array. We can also do something like this where we basically say letter is equal to names3 at dot char at 0. So I can take whatever name is in the third element, or I should say third, the number 3 element, because that's actually the fourth element. So whatever's in the number 3 element of names, we can grab the char at 0, which is the very first letter of that string item, and throw it into letter. So we've talked about numerics, which is primitive data types. We've done strings. We also can make arrays of objects themselves. So let's say we create a bank account object. So we've got a bank account class over here. Yeah, here it is. So here's our bank account. We've seen this in other chapters, in the previous chapter. We've got basically bank account. It looks like we have just one instance variable. We've got a no art constructor, a double signature constructor, and a string signature constructor. And again, only one of those constructors will be executed when this object is instantiated. And then there we've got our deposit. We've got, again, we're overloading these methods. We've got a deposit double signature and a deposit string signature. We've got a withdrawal, which only has a double signature, and a withdrawal that has a string signature. And then we have a set balance that's a double signature and a set balance with a string signature. And then we just have get balance. Okay? So, going back to the book, I can actually create. So right here I've got final, so I've got a constant called num accounts equal 5. And over here I can create an array of bank account objects called accounts. It's instantiated as a new bank account, and we do num accounts. Now the one thing you'll notice is we did not call the constructor here. You notice there's no left and right parentheses. And the reason for that is because we have to instantiate each individual element of that array. So when I come down here, I'm going to come into a for loop. And again, I create my integer index equals 0. Well, the index is less than accounts.length. We know the length is going to be 5 because that's what we set the array at. And we're going to come in here and we're going to say accounts index is equal to new bank account left and right parenthesis. So in this particular case, we're going to call the no arg constructor because there's nothing in the left and right parenthesis. So up here we create the array of objects, and down here is where we call the instantiation, because we have to instantiate each individual element of the array. And again, what we're really storing in each element is the address of that object. So when we reference that object, we're actually grabbing the address, and then we go to the address to deal with that particular item. So each element of the array, as it goes through this particular item, it's just going to set the balance equal to 0, because that's what the bank account does with a no arg constructor. So when we have a no arg constructor up here, it's going to set the balance equal to 0.0. So all 5 of those items, 0 through 4, are going to be basically, when we instantiate it, it's just going to set the balance equal to 0. And then if I wanted to, I could say accounts element number 2 dot set balance 2500, and accounts element 2 withdraw 500. So let's look at object array. We're going to expound on this. So here in my object array, I have my class object array. Here's my public static void main. I've created my constant called num accounts. It's set to 3. Okay, here's where I create my bank account array of objects. So I've got bank account, left and right parenthesis, or left and right square bracket, accounts. So the name of my array is called accounts. It's going to be instantiated as new bank account, but what we're doing here is we're just telling it how many elements we're going to have in this array. In this case, it's going to be 3. Then I call create accounts, and I'm going to pass the entire array to create accounts. So I come down here, and here we have private static void create accounts. I notice that it's private, meaning only this class has access to this method. We're receiving it as a bank account array because it's got the left right square bracket, and we're basically receiving the array in the parentheses there. I create a local variable that's a double. It's called balance. Here I have my scanner keyboard so I can get data from my user. And then I've got my for loop where I get my integer index equals 0. And while the index is less than the array dot length, we know that's a 3 because there's 3 elements in this array. We're going to go into this loop. Again, at the end, we're going to add 1 to the index. So I come in here and I say enter the balance for account index plus 1. Again, we don't want to say in account 0. We want to say account 1, account 2, account 3. And then I say balance equals keyboard next double. So I get the numeric value from my user. And then I say array index is equal to new. So this is where I instantiate the object. Up here, I've created a shell of all the objects. And they're each an element in the array. So they're empty objects at that point up here. They don't get instantiated till we're down here on line 56. So I'm going to grab the first element of the array. I'm going to instantiate it as a new bank account. And this time I'm going to pass the balance, which is a double. So what's going to happen there is it's going to call this constructor, since it has a double signature, and that's what it's going to do. It's going to set the balance equal to the start balance that was passed in. And it's going to do that for the next element, and the next, and the third element. When we come back from create accounts call, then we're going to say here are the balances for each object. We're going to go into the same exact for loop, and we're going to say account index plus 1, account index dot get balance. It's going to get the balance from each of those account objects. Should say bank account objects. Okay, so when we run it, it says enter the account for item 1, and let's type in 2,500. We'll hit the enter key. We'll do 5,000. Hit the enter key, and then we'll do 1,500. Hit the enter key, and then it says here are the balances for each account: 2,500, 5,000, and 1,500. Any questions on that? So the main focus there is to realize that when we create this array up here, notice we're saying new bank account, so we're thinking, hey, that looks like it's instantiating, but it's not. What we're doing is we're basically setting up the array. We're basically going to say how many elements are going to be in this array. And so again, what's happening is we've created an empty shell of a bank account object right here. It's got nothing inside of it. There's no methods, there's no instance variables, nothing like that. It's not until we get down here is where we actually do the true instantiation, because we got the left and right parentheses. So realize to do instantiation, to call a constructor, basically, we have to have the parentheses. Okay, so the next part of this book gets into this thing called a search array, a sequential search algorithm. And so the search algorithm is a method of locating a specific item in a larger collection of data. This section discusses the sequential search algorithm. Now, what this is called a linear search. And linear starts with L-I-N-E, which basically means we're going to go line by line by line searching for a particular item. So if I'm looking for the word Bob, I'm going to read the first one. Is that got Bob? No. The second one, has that got Bob? No. Is the third one got Bob? And I keep going. Maybe I'm at the 151st one. Does that one got Bob? Oh, yes, there's Bob. And then it basically stops and gives us back our search results. So that's a sequential search algorithm, or what's known as a linear search. Now, those can be very, very time consuming, because if I've got, let's say, 250,000 records, and it's got to go through each record looking for a specific item, it can take some time. It's doable, but it will take some time. So let's go ahead and open up search array. And there we see public class search array. This has got a public static void main. I create an integer array called tests, and I load it with 87, 75, 98, 100, and 82. I create a local variable called results. It's an integer data type. I'm going to say results is equal to sequential search tests 100. So I'm going to pass the entire array and the number 100 to the sequential search. And it's going to return an integer value, because results is an integer, so I'm expecting sequential search to return that. So I come down here to sequential search, and notice here I'm receiving an integer array called array. I'm also receiving an integer variable called value. I create 3 local variables: integer index, integer element, and Boolean found. I set my index equal to 0. I set my element equal to -1, and I set found equal to false. Then I go into a while loop, and I'll say while not found, which is false, and the index is less than the array.length. Okay? So what we're doing is, it looks like we're going to add down here on line 62, we're going to add 1 to the index every time we go through this. And the array.length is what? It's set to 1, 2, 3, 4, 5. So while the index is less than 5, because the length of the index, the length of this array is 5, we're going to go into this loop. And while found is equal false. Okay, so it's while it's not found, meaning not true. If the array index is equal to the value, remember we passed the 100 in here. If it's equal to that, we're going to say found equals true, and the element is equal to the index. And then we're going to add 1 to the index, which we wrote. It doesn't make any sense right now to do that. But anyways, we're going to return the element, okay, which is the index of that numeric value in the array. So once that happens, we come back, and we're going to say if results, because now look at this. We set results to -1. If we don't ever find what we're looking for in here, what's going to be returned in element? A -1. So I come up here and I'll say if results equals -1, we're going to print you did not earn 100 on any test. Else, if it's anything but a -1, then we're going to say you earned a 100 on a test. And it's going to return results plus 1. So, because remember, it's going to, remember, our arrays start with 0, 1, 2, 3, 4, so 0, 1, 2, 3, 4. Well, if I say you got earned a 100 on test results, that's going to basically be, it's going to show up as number 3. I'm going to say, I didn't score a 100 number 3. Well, that's why we add the 1 to it, so now it shows up as number 4. You earned a test on, you earned a 100 on test 4. Yep, 1, 2, 3, yep, 100. I got a 100, so that's basically showing that that is test 4. So let's go ahead and run this. And there it is. You earned 100 on test 4. Now, I'm going to change, you don't have to do this, so I'm going to change that 100 to 99, and I'm going to rerun it, and it says, you did not earn 100 on any test. Okay? I can basically then come over here and I'll say that, well, I'm going to leave that 99. I'm going to change this 75 to 100. And again, when I run it, it says you earned 100 on test 2. Sure enough, yep, on test 2 I scored 100. So again, no. Well, let's take a look at, well, let's before I say no. So if I marked more than one of those as 100, will they both show? Well, let's see what happens. As soon as this array index is equal to the value, look what it does. It says found equals true, and it sets the element to the index. So we come back around to this while loop. Is not found true? No, that's now false, because found is now true, so this statement right here, so it's going to drop completely out of that while loop. And when it comes back, so all we're going to get from results is the first found item. We won't get any others. Can we program around that? We most certainly can. We could just take this found out and just let it go through, but we would have to have another array basically to keep track of multiple test scores. Does that make sense? So I'd have to have a place to store multiple tests with 100. So what I would have to do there is, so I would basically do this. I'm going to do int tests equal new tests, and I want to say array dot length. Well, but in this particular case, we're trying to show you which test you got the 100 on. You see what I'm saying? So what I'm trying to do here is I'm trying to build an array of test scores. Shoot, so anyways, so I'm trying to, I can't remember how to do that. Right here. When we do this, when I find it, I'm going to return the index of that element in the array. I'm going to put that in this element variable, and that's what gets passed back. Because right here it says return element. That's what gets repassed back up here in results. So that's the index of where the first 100 was found. So anyways, what I'm trying to do here is I would create an array of test scores, and then what I would do is every time I would find, I wouldn't use this found anymore, but every time I found 100, I would then add that element to that array. And then what I would pass back is I would pass back that array to results. And then I would go through results as an array and say, you got 100 on this test, you got 100 on this test, you got 100 on this test. Or it might just be one test you got 100 on, or two tests, whatever the case may be, or no tests. But do you see what I'm saying? Okay. Okay. Okay, so here comes the fun part. We talked about this right at the end of class last time. Is two-dimensional arrays. And so two-dimensional arrays is an array of arrays. It can be thought of as having rows and columns. And that's probably the easiest way to think of it. So I might have 4 columns and 3 rows. So column 0, 1, 2, 3 and row 0, 1, 2. So how do we create a two-dimensional array? Well, I say double, left and right square bracket, left and right square bracket, scores equals new double, and then 3 and 4. So now we basically, looks like we're going to have 3 rows and 4 columns. Now, there's no rows and columns here, but we're trying to visualize in our mind how many rows and columns we have. So, how do I set these scores? Well, if I want to get data from score row 0, column 0, I would do scores 0, 0. Again, both of those are in 2 separate square brackets. And I can get 0, 1, 0, 2. So this is grabbing everything from row 0. And this is grabbing column 0, column 1, column 2, column 3. If I want to get everything from row 1, so notice everything's got 1 here in the first, and I grab 0 column, 1 column, 2 column, 3 column, and then here's the last row. Same thing. So again, this is pretty much how we're going to utilize each one of these elements of this array. So let's take a look at corp sales. So here we got a public static void main. I've got two constants, divs and quarters. So basically there's the divisions of a company and then the four quarters. And then I've got a local variable called total sales. I initialize it to 0.0. Here I create my two-dimensional array. I've got double, left and right square bracket, left and right square bracket, sales. So sales is the name of the array. And it's being instantiated as a new double. And then here's my divs and quarters. I've got a scanner keyboard. I do a sys out. This program will calculate the total sales of all the company's divisions, entering the following sales data. So now, notice I've got a for loop inside of a for loop. The first for loop is going to deal with the divisions, and inside of there is the quarters for each division. So the first time coming in, everything, the div is going to be a 0. But the first time through, quarter is a 0. Next time through, quarter is a 1. Next time through, quarter is a 2. Next time through, quarter is a 3. And then we drop out of this for loop. We come back up here, and we increase division by 1. So the next time through, div is a 1, quarter is a 0. Back through again, div is still a 1, quarter is a 1. Next time through, div is a 1, quarter is a 2. You kind of get the gist there. And what we're doing inside of here is we're saying sales, div, and quarter is equal to keyboard next double. And notice what we're doing at the end of each one of those is we're doing a sys out print ln. So we're printing a blank line. Because we want to basically have the next time we get something keyboard next double, we want that to show in its own line. Then when we get everything together, we go through the same exact for loop again. This time we're saying total sales plus equals sales, divs, and quarters. So we're grabbing each element of this array and we're adding it to total sales. And then we come over here and say that company sales were, looks like we're using a printf. And here's my percent, comma, 0.2. So we are rounding to 2 decimal places. We're going to use 1,000 separator, and we're using a floating decimal point, and we're going to put sales inside of that parentheses, or I'm sorry, percent sign. You with me? So I'm expecting this. I'm expecting to see this keyboard next double, this division quarters. Again, that's a printf as well. So basically it says division D and quarter D $sign is, instead of, again, we don't want to do division 0 and quarter 0. We want to do division 1 and quarter 1. So that's why we add 1 to the division. We should see this 12 times. So let's run it. I don't know what's blowing out. So here, this program will calculate total sales of all the company's divisions, enter the following sales data. So let's do this. Let's type a bunch of numbers in. I'm going to make it tens of thousands, like say 35,879.23. So just kind of keep doing that. You'll notice we're in division 1, quarter 2, quarter 3. I notice we got a blank line. This is where that blank line came into play, because it is showing a gap between the divisions. Because now we're on division 2, quarter 1. Again, now we're in the third division. There's the nice blank line to basically kind of show the gap between the divisions. We're now in Division 3, Quarter 1. And when I get done, there's my total sales. So again, this really makes it easy to kind of understand how we can use these two dimensional arrays by, again, kind of conceptualizing the rows and the columns. In this case, we're doing divisions and quarters. We got 3 divisions, and I want to see the sales for each quarter for each division. So we load that into a 2-dimensional array, and it's real easy to pick out what are each division and then the quarter for each one of those divisions. So does that make sense? So not too bad. I mean, if you ever used Excel, that makes it easy to kind of understand that. Now, we've created and initialized other arrays. Can we do the same thing for a 2-dimensional array? We most certainly can. So look at this. Here I've got int, left and right square bracket, left and right square bracket, numbers. Numbers is the name of the array. It's an integer data type. Notice I've got a left brace here, and I've got a left open brace here. I've got 1, 2, 3, then a closing brace. And then 4, 5, 6 is in its own set of braces, and 7, 8, 9 is its own braces. So if you look at this, we have a 1, 2, 3 rows with 1, 2, 3 columns in each row. So that's how we kind of establish our rows and columns. Each grouping is a row, and then each number inside of each of those groups is a column. So we can kind of think of it this way, where in row 1, I've got 1, 2, 3. Now this might be the better way to kind of create that so we can visualize it better. We can now see that, oh, this is row 1, this is row 2, and this is row 3. So it's easier to conceptualize the rows and columns when we basically write it this way. And so again, they're saying that 1 is in 0, 0, 2 is in 0, 1, 3 is in 0, 2, so on and so forth. So now what is the length field in a 2-dimensional array? Well, we got a whole lot of stuff going on inside of here, so how do we figure out the length? So let's open up the lengths.java. Let's take a look at it. So here I've got a 2-dimensional array. So I can see 2 sets of square brackets. Its numbers is the name of the array, and row 1 has 1, 2, 3, 4. Row 2 has 5, 6, 7, 8, and row 3 has 9, 10, 11, 12. It says we're going to print the number of rows, numbers.length. So here's the deal. When we just say dot length of numbers, it's going to be using these outside braces first. So it's going to show me all the groups inside these first set of braces. That's what the number is going to come back. And what's going to come back is the number 3. Because there's 3 groups of items inside of these first braces. Now, So how do we get inside the other ones? Well, let's take a look. So I've got my for loop here, and it says for index equals 0. Again, that gets executed only once at the beginning. Now here's our check. While the index is less than numbers.length, in this case it's 3, we're going to go into this loop. At the end, we're going to add 1 to index. So I come in here, I'm going to say the number of columns in row index is, now look at this, numbers index. Oh, wow, this is kind of strange. This is a two-dimensional array, but I've only got, I'm only using one index. Well, that index is for the row. So it's looking at the row, and then I can say dot length for the row. How many elements are in the row array? And it's going to return 4 as the length. We read the next row, and it's going to do the same thing. So we should see, this should just print 3 sets of 4 is what it will print. So if we run this, did I screw something up? Oh, that's right, the search array, I'll get rid of that so I don't see that anymore. Oh. Yeah, I got rid of that. Okay. Okay, so notice the number of rows is 3. So up here, the number of rows is numbers.length. That's going to show the 3 groupings. The number of columns in row 0, right here, is numbers index. So it's looking at just this first group. Dot length is 4. Same thing for the second group, and same thing for the third group. So in order to use lengths, we can get the length, so the default length for the array itself is going to show the number of rows. Then we have to go into each row and use the length for that row to get the number of columns for each row. Does that make sense? Summing all the elements on a two-dimensional array. So again, we've seen this. We got a for loop inside of a for loop. So the first one goes in through each row, and then the second for loop goes into each column, and we just basically do a total. So we've done that in the previous one. Summing the rows of a two-dimensional array. So I've got for int row numbers.length. So I go into my for loop for the row, and it says while the row is equals 0, and while row is less than numbers.length, and that's going to basically deals with just the rows, each grouping, we're going to set total equals 0. And then we're going to come in here, and now we're going to do int col equals 0. And while col is less than numbers, now look what row we're in, dot length, and now we're dealing with each individual column. We're going to say total plus equal numbers row column. And I want to, and at the end, so outside of that for loop, we're now going to say total of row is total. So what this is doing, this is totaling each row. And it's showing the total for just that row. So we basically add up all the columns, display the total, add up all the columns, display the total, add up all the columns. Summing the columns of a two-dimensional array. So that adds all the rows together. How do we add all the columns together? So again, here I've got my two-dimensional array, 3 rows, 4 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got an int total here, so it's basically a local variable. And then I'm going to have my for loop. This time I'm going to start with the column. I'm going to make the column my outside loop. And I'm going to go into each row then. So what it's going to basically do is this. It's going to take 1 and add to 5 and add to 9. It's going to take 2, add to 6, and then add 10. 3 plus 7 plus 11. And so that's basically what we're doing here. So we're starting with the column. And we're going to go through numbers 0 dot length. And then we're going to say row equals 0, and then while the rows number dot length. So, and we're just going to add rows. Yep. So it looks a little different, but now the weird thing is notice I've got a 0 hard coded right here. Really, I'm not really worried about what row I'm in for this for loop. I just want to go through the 4 columns. So that's really all we want to do at this point, is because the dot length of the first row is 4. So we're going to go through 1, then 2, then 3, then 4. And the only thing this for loop does is set the total equal to 0. Now this is where all the heavy lifting is done, is in this for loop right here, is I got my int row equals 0, and while the row is less than numbers dot length, again that's basically 1, 2, 3. We're going to add the total of the column. Anyways, we're going to say total plus equal numbers, row, and column. So notice this time row changes each time, but column stays the same. So while we're in column 0, we're going to grab row 0, which is 1. Next time through this loop, column is still 0. We're going to grab row 2. Come back around. Column is still 0, row is now 3. We're down out of that loop. We come down here and say the total of column is the total. Then we come back to this loop. We now increase our column by 1. We set total equals 0, and we go back into this for loop again. Now column is 1, row is 0. We add that to total. Come back around, column is still 1, and row is 1. We add that to total. Next time around, column is still 1 and row is 2. We add that to total. We drop out of that loop, and now we basically display the total for that column. Now, this is kind of strange. We can pass a 2-dimensional array just like we can any other array. So let's look at pass 2D array. So let's take a look at this guy. And here we've got our 2-dimensional array. So here it is. We've got 1, 2, 3 rows and then 4 columns in each row. It says here are the values of the array. Show array numbers. So we're passing numbers down here to show array. Now notice the show array is receiving a 2-dimensional array because I see 2 sets of square brackets. That's called array. Here's my outer and inner loop. So my outer loop is the row. The inner loop is the columns. And so it's going to display row 0, column 1, row 0, column, row 0, column 0, row 0, column 1, row 0, column 2, so on and so forth. And then it's going to print a new line and do the same thing again. So when we run it, let's do this. We're not done. So then it says the sum of the array values is array sum numbers. It's going to pass that array down there as well. So show array displays the different columns for each row. Then we pass array sum. Again, it's receiving it as a 2-dimensional array. It's going to be called array as well. We got int total equals 0. And here we're going to do the same exact for loop, except in this case we're just going to take what's in each element and add it to total, and then we return total, and that's where it basically gets printed right here. So let's run it. And there it is. Here are the values in the array. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The assembly of values is 78. It can hold anything. An array can hold anything. An array can hold objects. It can hold primitive values, which are numerics. It can hold strings. It can hold anything. It can hold chars. It can hold anything. That probably didn't help, did it? Now, this next one is really kind of wild, and it's called a ragged array. And ragged arrays are two-dimensional arrays, but each row won't have the same number of columns. So, here I create my int, left and right square bracket, left and right square bracket, ragged is equal to new int. Now notice we've got a 4 here, but nothing in the second square brackets. So we're saying we've got 4 rows, but we don't know how many columns there are. So I come in here and I'm going to say ragged 0. Now notice when I deal with just a 1 square bracket, that means I'm dealing with the row all by itself. I'm going to instantiate it as a new int 3. So that says row 0 is going to have 3 columns. Row 1 is going to have 4 columns. Row 2 is going to have 5 columns, and row 3 is going to have 6 columns. So, in this particular for loop, we're going to basically look at, we're going to go through the length. So now when I say the array.length, I'm actually dealing with just the rows. So in this case here, it's going to go through it's going to go through this for loop 4 times. And so the number of columns in row index is ragged index. So it's going to show the length of each row. And so what that's going to display is the number of columns in row 0 is 3. The number of columns in row 1 is 4. The number of columns in rows 2 is 5. The number of columns in row 3 is 6. Now, you notice they didn't really talk about any examples for this, because they just want to kind of introduce it. Because I'm try to think of a situation where you would need a ragged array. So maybe you know that there are. Well, let's talk about students. Does every student take every test? Well, probably not. So when we're talking about number of tests, maybe Steve, out of 6 tests, he made 4 of them, and Sally, she made all 6. Okay, and George, he only was able to get 2 tests. And I might create a ragged array by the number of tests each student did. Probably not the best example, but it's one I can think of top of my head. Because normally I would just make every student have a 6-element array. Yeah. Anyways, because if they didn't take a test, I'd give them a 0. But anyways, so you kind of get the gist there. I'm sure there's a reason why someone would want a ragged array, but just realize that we can do it in a 2-dimensional array. Now, I don't think they have. Do they have any examples of this? Yeah, I don't think they did. So let's just talk about 3-dimensional arrays. So look at this. I've got, now again, can you have a 4-dimensional array or 5-dimensional array? You can, but man, it really gets hard to understand. So here I've got double, square brackets, square brackets, square brackets. That means it's a 3-dimensional array. Name of this array is seats. And it's equal to new double. It's going to have 3, we'll call them panels, 5 rows, and 8 columns each. Okay? So think of it as 3-dimensional now. I've got this panel, and there's my rows and columns, Here's the next panel, rows and columns, and here's the next panel, rows and columns. So now in order to get to, they're calling them pages. So in order to get to this box right here, I'd have to go to page 1, row 1, column 3. To get to this one back here, that would be page 2, row 0, column 2. Yep. You would need 3 loops. Two nested loops inside of 1 loop. Yep. Because that outside loop would have to deal with the page, the next loop would have to deal with each row, and then the last loop would deal with each column. Now, I don't know if they have an example of this. I don't think they do. Yeah. Or did I create one? I can't remember. I might have created one. Let's see. No, I don't think I did. This next one is called a binary search. So here's what I want you to think about a binary search. So the very first thing that we have to do in a binary search is we have to sort everything. It has to be in a sorted order. So here's how binary, so we know what a linear search does. Linear search goes line by line by line looking for something. And that can take a very, very long time. So think of a database having 100,000 lines of data, and you've got to go through each one of those lines looking for a specific item. Well, again, it's doable with a linear search, but it will take a while because it has to read each line and figure it out. Now, with a binary search, here's what we do. So let's say I've got a list of 100 numbers, and I'm looking for the number 82. Okay. First thing I do is I sort everything. So it's 1 through 100. It's already sorted. Is I cut that in half, and I'll say, is 82 in this first half, or is 82 in this bottom half? Oh, it's in this bottom half? Then I'll take just that bottom half, and I'll cut it in 2. So now I'm looking at 50 through 75 and 76 through 100. Is it in the top half or the bottom half? Oh, it's in the bottom half, which is 76 through 100. It cuts that in 2. And it says, oh, is it in the top half or the bottom half? No, it's in the bottom half again. It just takes that section. So as you can see, I think the number is it cuts it in half 7 times before it narrows it down. So do you see how fast that is? That's super, super fast. I don't care how many thousands and thousands of rows you have, a binary search cuts it in half, cuts it in half, cuts it in half, cuts it in half, and narrows it down very, very quickly to find that particular item. But what can take some time is doing the sort. So the first thing we have to do is a sort algorithm. And so what this sort is also called a bubble sort. And so what it does is think of numbers. The larger numbers keep floating to the top, okay? Or well, let's do it in reverse. The lighter numbers, the smaller numbers keep falling to the top. So in this case here, I've got 5, 7, 2, 8, 9, 1. So the very first thing we do in this particular sort, is I take the first 2 elements and I swap them. Then the next thing I do, why did they do the swap? So the selection sort scans the array starting at element 0, locates the element with the smallest value. Okay, I see what it does. The content of this element are then swapped to the content. So it basically looks for the smallest numeric value in this array. And once it finds it, it puts that into the number 1 position. Okay? It actually swaps. It doesn't care what's in the number 1 position. It just swaps the 5 and the 1. Okay, so after that, it goes to the array again. This time the algorithm begins with the scan at element 1, because we don't have to worry about this first one anymore. We know the lowest number's there. So now we're going to start here. And it was number 7. Okay. And this time it looks for, so it says, in this example, the contents 2 are exchanged. So it starts at element 1 and looks for the smallest number. Oh, it finds it here, or it was actually right here. Number 2 is here, and number 7 was here. It's just going to do a swap of those two. Now, if the 2 was here, it would then do the same exact thing. It would swap this guy with that guy, and it puts number 2 there. Then it starts at element 2 now. It's already got the smallest in 1 or in 0, and then it has 2 in the second element, which is element 1, and now it's going to start in element 2, and it's going to go this way looking for the smallest number. It finds it. So what it does is it swaps element 5 with element 2, so now it's got 5. It's got 1, 2, 5. Then it goes to element 3 and searches to the right and finds the smallest number. And there is number 7. It then does a swap of those two. It swaps those two items. Those two elements, I should say. Then it goes from element 4 and goes to the right, finds the smallest number, and it basically makes sure that that smallest number is, and if it has to do a swap, it'll swap those two as well. So when it gets done, it's going to have everything sorted in order. Exactly. And it always makes sure that it puts it in the next element. So it gets the smallest one, puts it in the very first. It always does a swap. Then it starts at the search and this one looking for the next. Oh, it finds it and it swaps those two. Then it goes to the next position, goes to the right, finds a small. Oh, it finds that and it swaps those two. And it keeps swapping. Sometimes it doesn't have to do a swap. It just leaves everything alone at that point. So here's basically the code to basically do that. And I had this at one time. Actually, I'll make sure I have that in the next class. Okay, so then the next part. So now once we got it sorted, now we can do our binary search. And so, and here's the code for that. So here's what it's got to do is we're going to start in position 0. Set the last to the last subscript in the array. We're going to set the position, so set last to the last subscript in the array. So if I've got 10 elements in my array, that last element's going to be element 9, because it always starts with 0. So first is going to be 0, last is going to be 9. We're going to set the position to -1. We're going to set found equal to false. Now we go into our while loop. While found is not true, and the first is less than or equal to last, while that's true, we're going to come in here. We're going to set middle to the subscript halfway between array first and array last. Okay? That would be number 5. We've got 10 elements in an array. If array middle equals the desired value, set found equals true, set position to middle. Else, if array middle is greater than the desired value, we're going to set last to middle, we're going to set last to middle minus 1. So if the middle was 5 and what we found was greater than that, then we're going to set middle to 5 minus 1, which is now 4. Else we're going to set, if that's the case, that means it's in the lower half, we're going to set middle to, set first to middle plus 1. No, I just said that wrong. Right. So if what we found is greater, then that means we want to go into lower half, so we set the middle minus 1, which is 4, so it's going to be 0 through 4. But if it's greater or less than that, then we basically want to start to the upper half and basically set middle first is middle plus 1, so the very first location. So now once we've done that, now we've got our first is set to 6 and last is set to 9. If it was the other way, it would have still been, first would have been set at 0 and last would have been set at 4. And then we basically keep doing that. Remember, we keep chopping the middle and we keep finding which it's in. And then when we get done, we return the position, and that will basically be, that should find what we're looking for. And here's the code for that as well. Again, I'm not expecting you to understand it, but this is really something that yeah, I'll try to get this created and I'll send it to you guys if you want to play around with it. I'm just going to touch on this because I just, for some reason, I just can't get this to work. But we can go through a command prompt window and actually run Java and then actually have it run a program. So here's the command line that we could actually utilize if I could get it to work. I could actually open a command prompt. Well, let me just do this. And from here, I could type, I should be able to type Java and then the program name, and with any parameters, and I should be able to execute this code right here. So I should be able to type Java and then the path to this command line program, and in there I could actually then put in some arguments, and so I would actually type, how does this work, question mark. I would say Java command line, and inside the parentheses for command line I would put, how does this work, question mark. And what would happen, these arguments that would be utilized down here would say, so we'd create a for loop, create our integer index equals 0, and while the index is less than args.length. So what args is going to do is it's going to actually be put into like an array. So it knows that it's going to be 1, 2, 3, 4 is the length. And we're going to come in here, we're going to say, okay, print args index. So basically args is now is an array, and it's going to print each one of these words I typed in the parentheses. Like I said, I tried to get this to work. For some reason, my system just would not run this, but that's basically what the command line prompt is utilized for. And that's we've seen this strings, args, and all of our public static void mains, and that's really where that would come into play. Apache, well, it's basically, it's the JRE, the Java runtime environment. Are you asking, is it like Linux or is it something like that? That ipconfig, that's all Windows based. Java is its own language. It's its own runtime environment. So yeah. variable length argument lists. So Java provides a mechanism known as variable length argument lists, which makes it possible to write a method that takes a variable number of arguments. Okay, in other words, you can write a method that accepts any number of arguments when it's called. This method is, when this method runs, it can determine the number of arguments that are passed to it accordingly. So let's say I've got a sum method. And here I've got result equals sum 10, 20. But I might put result equals sum 10, 20, 30. So how does it handle that? Well, inside of the sum, I've got int ... And that says, hey, there could be multiple integers being put in here. And so what it's going to do is it's just going to default these two numbers in an array called numbers. And so then inside here I've got int total equals 0, so there's my accumulator. And here's my for loop. We're going to use an enhanced for loop. I'm going to say numbers array. I'm going to grab each element of this numbers array, throw it into this val, and then I'm just going to say total plus equal val, and then I just return the total. That's it. That's as easy as it gets. So int ... is basically saying I'm going to create an array. I'm going to create an array, or I might not create an array, depending on how many numbers are passed in. But basically, I am going to have an array. It's always going to be an array, but it might be an array of just one row. It might be an array of 5 rows. I don't know. But that's what the ... is for. So here's another example. I've got int first val equals 1, second val equals 2, third val equals 3, fourth val equals 4. And here I've got result equals sum, those 4 numbers. This method can handle it. That method can handle that, or this method can handle this. Just 2 parameters. So that type of parameter is known as a vararg parameter. A vararg parameter can take variable numbers of arguments. Let's take a look at vararg's demo 2. And so here I've got bank account 1, 2, 3, and then I'm going to basically ask you to get the balance for each one. And now notice that in this particular one here, there's a method called total balance down here. Notice it's got bank account ... accounts. So total. So here I've got my 3 bank accounts, and I'm going to initialize the bank accounts with a double. 100, 0, 500, 0, 1500, 0. And so when each of those objects get created, it's going to have a balance in each one. And then I say total is equal to total balance account 1. And that's going to basically grab the balance for this first account, or bank account, and it's going to basically put it into total. Then on line 27, I say total is equal to total bank account 2, account 1, and account 2.
Hello?
And so what that's going to do is that's going to add 100 and 500 together. And then this last one, total, is the total balance account 1, account 2, and account 3. And again, that's going to receive these bank account objects, each one, and that's what it's basically going to come in here and say for bank account object, accounts. Again, accounts is an array. It's going to grab each element one at a time and throw it to account object, and that's where it's going to basically total each. It's going to say account object.get balance, and it's going to basically add that to total and then return the total. So this first one going through, it's just got one account. It's basically a single element array, But it's going to grab that, throw it into count object, and then come in here and add that to total, and then return the total. So when we run it, there we have a total of 100 because we only had a count 1 in there. The next one is 100 and 500, which is a total of 600. And then the last one is 100, 500, and 1500, which ends up being 2100. All three of those added together. So vararg methods. Yep. Okay. Yeah. So 500 and 1500 is 2000, and then adding to 100 is 2100. Okay. Now this is the last section, I believe. Yeah. And we're going to talk about array list class. So with arrays, we're kind of limited to what we can utilize or what we can do with them. So for example, like I said, once I set the number of elements in the array, I can't change it. Remember how we basically found out that when I do change the size of an array, it actually wipes out the old array and creates a new array with those elements. Now there's a way to, it's kind of a long drawn out process, but there is a way to resize an array. So let's say I wanted to get rid of element number 3 out of a 4-element array. Well, what I would have to do is create a new 3-element array and then grab element 0, element 1, and element 3 from the other array and put them in this new array. Well, and then I would just wipe out that other array. So that's the only way we could do that with a normal array. Well, Java came up with this new thing called the array list class, and it's very, very powerful. So the array list class is a Java API that is similar to an array that allows you to store objects. Unlike the array list object size is automatically adjusted to accommodate the number of items being stored in it, which means we can actually add items to an array, we can take items out of an array. So we can add the number of elements, and we can basically take away the number of elements. An array object automatically expands as it's added to. In addition to adding items to the array list, you can remove items as well. The array list object automatically shrinks as items are removed from it. So how do we do it? Well, the first thing we need is we do need to import the array list. And so how do we create an array list? Well, I say array list, and then this time we're using greater than and less than symbols. And inside those, I'm going to tell it what is the data type for this array list. So in this case here, I've got an array list. It's going to be a string data type. The name of the array list is going to be called nameList, and it's going to be instantiated as a new array list. Again, we have to include the data type there as well, and then our left and right parentheses. That's the constructor. Now, once I have my nameList created, which is an array list, I can just say namelist.add James. So right here, when I create the array list, there's no bookshelves, there's no elements. It's just empty. When I come down here and I say namelist.add James, it adds a bookshelf and puts James on it. When I say namelist.add Catherine, it adds another bookshelf and puts Catherine on that bookshelf. And when I say namelist.add Bill, it adds another bookshelf and puts Bill on that bookshelf. And then I can say the array list has namelist.size. With our array, we use the length. But in array list, we use the dot size. That will tell us how many elements are in the array. And in this case, it would say the array list has 3 objects stored in it. If I need to get something out of an array list, I can say namelist.get1. Now these are numbered exactly like arrays are. So in this case, it's 0, 1, and 2. In this case, it's going to get namelist get1, which is going to be Catherine. Okay, so here I've got, this looks a lot better. So here I've got array list string. So the string is the data type, and we have to do that with the left and right, with the less than and greater than symbol. I'm going to create my name list. It's a new array list string, and we got the left and right parentheses, which basically is our constructor. No our constructor in this case. And I do namelist.add_James, namelist.add_Catherine, and namelist.add_Bill. So like I said just a few minutes ago, it added a bookshelf and put James on it. It added another bookshelf and put Catherine on it. And it added a third bookshelf and put Bill on it. And then it just says the array list has namelist.size object stored in it. And then I'm going to go through my for loop, and I'm going to say int index equals 0. And while the index is less than the namelist.size, and the namelist.size, as we saw right here, is a 3, we're going to come in here and I'm going to print ln namelist.getIndex. So get 0, it's going to bring back James. Get 1, it's going to bring back Catherine. And get 2, it's going to bring back Bill. So when I run it, it says the array list has 3 objects stored in it: James, Catherine, Bill. Any questions on that? Now, we can use an enhanced for loop for the array list. So let's take a look at array list demo 2. So here we have the same exact process. Got my array list. Name list is a new array list. Again, it's a string data type. I'm going to add James. I'm going to add Catherine. I'm going to add Bill. I'm going to say the array list has namelist.size stored in it. So to say 3 objects stored in it. Then instead of the other for loop that we saw in the previous one, I'm going to use an enhanced for loop. So here I'm going to say namelist name. So it's going to grab each item, each element out of the array list and put it into name. And then I'm just going to print name. So big difference between this with using a get. I'm just going to use an enhanced for loop, and notice it really shortens it up. There's not a whole lot of code for that. And we should get the same exact results. And sure enough, there it is. The array list has 3 objects stored in it: James, Catherine, and Bill. So let's remove an item from the array list. So let's open up array list demo 3. And same exact, up to the for loop, everything's the same. We create our array list. It's a string array list called namelist. I add James, I add Catherine, I add Bill. Then I go into the for loop. And I'm going to basically create an index, enter your index set to 0. While the index is less than the namelist.size, which is 3, we're going to go into this loop. And I'm going to say index, and then name, namelist get index. So it's going to basically print the index number, the name, and what the name is. Okay. Now look at this. Now before we continue, I'm going to type a period behind namelist here. Let's see how many different methods we have. Well, look at that. I've got add, a string, add an int, add all, add first, add last, clear, clone. Boy, the list just goes on and on and on. So the array list has a lot of methods in it. And one of the methods it has is the dot remove. So this says name list dot remove 1. That means it's going, because James is 0, Catherine is 1, and Bill is 2. That means it's going to remove Catherine. It says the item at index 1 is removed. Here are the items now. Now we go back to the for loop. What's the size of our loop now? So when I say the size of our array list, it's now just got 2 elements in it. So now here's what happens. James is still 0, but Bill slides up in the number 2 spot, and it's element number 1. So James is 0, Bill is 1. So it's going to come in here and say index, index, name, and it's going to get the name of each of those and display it. So let's run it. And there it says index 0, name James, index 1, name Catherine, index 2, name Bill. The item at index 1 is removed. Here are the items now. Index 0, name James, index 1, named Bill. So array lists a lot more powerful. We have a lot more control over how we basically with the elements in our array. With the other array, we're kind of stuck with, if we got 50 elements, we're kind of stuck with those 50 elements. I can't get rid of an element. I have to keep it. Right, right. It basically, think of it this way. Think of a guy in there, he's basically shuffling things around and renumbering. And that's kind of what the JRE is doing, is it's taking that array list and it says, okay, you've got this James in this 0 slot and Catherine in this number 1 slot and Bill down here. Oh, we're going to get rid of Catherine, so we take that away and then we just renumber the index for Bill to number 1. And at some point, the garbage collector will take Catherine and basically get rid of Catherine. I don't, man. If we want to get into the, we really don't want to get into the memory part of it, because when that gets super ugly, we get into hexadecimal and all kinds of crazy things. Octal. There's actually some octal things in there. So, okay. So now let's insert an item. So let's do this. Let's look at ArrayList Demo 4. Same exact thing. We create our array list. It's called name list. I add James, I add Catherine, I add Bill. Then I got my for loop where I'm basically doing the same exact thing. I'm going to list all of the different items by their index as well. Then I come down here on line 28, I do namelist.add 1 Mary. So here's what this does. This says I'm going to add Mary at position 1, or element 1. So what happens there is Catherine's sitting here at element 1, Catherine gets shifted down to element 2, and Bill gets shifted down to element 3, and now Mary is sitting there at element 1. So now when we run the same exact for loop, the size now went from 3 to 4, and now when we run it, we should see, well, let's just run it and so we can see what it actually does. Yeah, so now down here, index 1 is now Mary, and index 2 is now Catherine, and index 3 is Bill. So look this way up here at first. 0 is James, 1 is Catherine, 2 is Bill. But once Mary is added at index 1, here are the items now. James 0, Mary 1, Catherine 2, Bill 3. Catherine keeps getting picked on. She got deleted in the last one. This time here she got shifted down. So she lost her spot. Okay, so we can add, we can delete, and we can insert. The next thing we want to do is replace. So insert kind of pushes two bookshelves apart from each other and puts a new bookshelf in there. Replace just replaces what's over on a bookshelf, so it gets rid of one and puts it in there. So here's namelist.set1 Becky. So the Catherine is going to be replaced with Becky if we run that guy. So let's open up ArrayList Demo 5. So again, we create our array list on line 13. We add James, we add Catherine, we add Bill. We step through the for loop to basically see the index and the name. And then down here on line 28, I do namelist.set1 Becky. That says in element number 1, I want you to replace what's ever in there with the name Becky. Then we print Catherine was replaced with Becky. Here are the items now, and we step through the loop. Now the size did not change. The size stayed 3. It just Catherine, she keeps getting picked on for some reason. She got removed and Becky took her place. So now when we run it, so James is still 0, Catherine is 1, Bill is 2. Catherine was placed with Becky, so here they are now. James is 0, Becky is now 1, and Bill remains 2. So we've got add, we've got remove, we've got insert, and we've got replace. So it says previously learned that an arrays list object size is the number of items stored in the array list object. When you add an item to the array list object, its size increases by 1. And when you remove an item from the array list object, it decreases by 1. An array list object also has capacity, which is the number of items it can store without having to increase size. When an array list object is first created using a no-arg constructor, it has an initial capacity of 10 items. This means it can hold up to 10 items without having to increase size. When the 11th item is added, the array list object must increase its size to accommodate its new item. You can specify different starting capacity if you desire by passing an int argument to the array list constructor. So for example, the following statement increases or creates an array list object with the initial capacity of 100 items. So here I create my array list. It's a string array list called list. New array list, it's a string. Notice I've got 100 in the parentheses. That says I've now increased the size of this, the default size, to 100. Now, when it says it has to increase its size, that's actually taken care of for us behind the scenes. So it's really nothing we have to do. But again, the memory has to be shifted around, all that kind of crazy stuff. But if we initially say, I'm going to have 100 items in this array list, it basically gets it all set up in memory. And so none of that shifting or none of that stuff has to be moved around. It basically creates this nice table saying, okay, I'm ready to add 100. So let's take a look at ArrayList Demo 6. And ArrayList Demo 6 is now using objects for the array list. So the array list is going to make a bank account object. Okay? It's a data type of bank account. The name of this array list is called list. It's going to be instantiated as a new array list of the bank account object type. Then I come down here and I'm say list.add new bank account 100. Whoa, what's going on there? Well, here's what's going on here. Up here, we created objects. I think it said it defaulted 10, but it basically created bank account objects. They're empty shells of an object. But when I come down here and do an add, all I have to do is say new bank account 100. This is the instantiation right here. And it's basically got a double argument which means it's going to call the double signature constructor, which sets the balance to 100. And when I basically do line 18, it's going to add and instantiate a new bank account of 500 in the balance. And line 19 is going to instantiate a new bank account of $1,500 in the balance. And so when it gets through, so after it executes line 1, it's got a 1 element in the array list. When it executes line 18, it now has 2 elements in there. When it executes line 19, it has 3 elements in there. Then I can come in here and basically do a for loop where I do my index. Well, the index is less than list.size, which in this case the size is 3. I'm going to come in here and I'm going to say bank account is equal to list.getIndex. Now, here's what's happening here. On line 24, I'm creating a new bank account item, which is an object. It's creating a new bank account object called account. When I say list.getIndex, so the first time through, it's going to grab this bank account object and put it into this account object. So that's kind of the instantiation that it does. I can take an object and throw it into another object as the instantiation. So after it executes line 24, I now have an account object, and then I can say account at index, new line balance, account.getBalance. When we come back around and do this loop again, on line 24, it's going to create even a newer object called account. And again, it instantiates it with this 500 balance bank account. And then when it comes to this loop again, on executes line 24, it creates a new account object, which is a bank account object. And again, it's going to grab this 1,500 balance bank account object and instantiate it into this account object. It's overriding the same object. Well, it's actually doing this. It's taking that first account object and pushing it aside, deleting it, and creating a new account object. Again, the garbage collector will take care of that one that was pushed aside. Does that make sense? So it's kind of deleted, pushes it aside, and creates a new bank account object called account. Exactly. Just to get each object into an object we can utilize what's inside of here. Because I think we could have done this. We could have said, I think I could have said plus list dot, oh, what in the heck's going on? Oh, I know. I got to put in parentheses. I'm just going to try to do an addition. So if I come in here, dot,
I don't know. Her face is all
let's see.
swollen.
So if I do, see, list.getIndex, and I want to do the get balance. Can I do that? Yeah. Here, let me do this instead. Yeah. See, I don't know why they just didn't do that. They could have just said, we wouldn't even need this thing. I could have just said list.getIndex.getBalance. I think what they're trying to do here is show that you can create an object, a new object, and instantiate an existing object into that new object. This is really how it should have been done right here. It's just exactly, yeah, yeah. You've already got the object. You've already got the object. You've already got the balance. Just say list.getIndex. So it's going to grab that specific, so whatever the index is for our for loop, and then just grab the get balance from that. That'd probably been, I think we should still get the same exact. Whoop. Yeah, a count at index 0 is 100. Yeah, index 1. Yeah. Right. Right. Okay. One thing I do want to kind of go back to, it's over on page, about on page 475. And that is, and that is array list classes do have a toString method. Okay. So the example they have here is system.out_print name list, and it's going to print James, Catherine, and Bill. So if I go to, I'm going to reopen ArrayList Demo 2, and I can actually come down here and do syso. And I'm just going to say name list. So when we run it, see how it prints it? It prints it James, Catherine, and Bill. And it puts square brackets around it. The square brackets are there just to let you know that this is an array list. Or it should say, this is some type of an array. So the square brackets are there to say, this is some type of an array. It's got 3 elements in it. It's got James, Catherine, and Bill. So it does have a toList parameter to it. I think, let's see. One last thing they kind of cover there on page 480. Is using the diamond operator for type references. That basically was new in Java version 7, and I think 7 came out maybe 10, 15 years ago. So I won't say it's new, but it's not that old. And so that's basically where they call it the diamond operator. It's the less than and greater than symbols. So we can basically, so in there we could actually have that be. Now, if I wanted to make it an integer data type, what goes inside the diamonds must be a class. So remember, we've got the uppercase I integer class, the uppercase D double, the uppercase B short, uppercase B char. So we basically have to utilize a class. I can't put a lowercase int in here. I can't put the lowercase double in here. So that's the one requirement for the diamond operator, is it must have a class inside here. Sure. I don't think so, because there's no way to put a 2-dimensional, 3-dimensional array list, because there's no, the square brackets that we have. There's nowhere to put those to tell it to be a 2 or 3-dimensional array. Now there may be a parameter I'm not aware of that says, hey, make this a 2-dimensional array, But as far as we know, there's no way to do it.